All right, hello there. So we are going to pick up where we left off. We were going through lesson 13.5, which is um, on uh, the common logarithm, natural logarithm, and some applications. So we talked about the common logarithm last time. A common logarithm is one where you don't see a base written. And when you don't see any base written and it's log with no base, that means the base is 10. So that's called a common logarithm. It's used very commonly, so we just assume that it's 10 if you don't see a base. So we started out, we evaluated logarithms by hand without a calculator that were base 10. I can do one quick example here, this one right here. So let's say you're trying to evaluate the log, so this is what we started with, the log of 100. What that means is remember when we're evaluating a logarithm, we're trying to find an exponent. We use logarithms to find exponents. So if there's no base written, its base is 10. And so we're trying to figure out what does this equal. Well, what we're finding is 10 to what power is equal to 100. And of course, it would be 10 squared because 10 squared is 100. And if 10 to the x equals 10 to the second, then our exponent here must be equal to 2. So that's how we got this answer. And similar processes for B, C, D, E, and F. So moving on to the next example is evaluating common logarithms, and we did a few of these as well last time. I'm going to go back over this using the log key on your calculator. So your calculator has two log buttons. One of them right here is right there, they're highlighted in red. That is, let me clear all this. That is, let me extend that as well. That log button right there is, let me clear all that. Log is base 10. The one right underneath it, and you can see right above it has an e to the x. The ln, this log button, is base e, and we'll cover that in just a bit. So I'm going to, since this log button on the calculator is base 10, and all of these G, H, I, and J are all base 10 because there's no base written for any of these. We know they're base 10, so you can just type in log of 7.02 and you get 0.846. And that answer, this 0.846 that we get, is telling us that if I raise 10 to that power, I will get 7.02. And I have approximately equal to because this number is rounded. All right, so if we punch in log of 1.39, and all calculators should have this feature if they are scientific. I already have the log there, 1.39. What this is going to tell me is 10 to what power is equal to 1.39. And if you think about it, 10 to the first is 10, so that's too big. 10 to the 0, anything to the 0 is always 1. That's too small. So it's going to be a decimal, but it's going to be a positive value, probably closer to 0 because 1.39 is a lot closer to 1 than it is to 10. So if I type that into the calculator, the log of 1.39, and hit enter, I get 0.14301. So approximately 0.143. And if you want to check that, you can take 10 and raise it to that number, and I can do that with my graphing calculator just by hitting second answer. Hit enter, and I get 1.39. Okay, so the rest you can just type those in to the calculator. Log of 6. You're going to just type log of 6 and enter. You may have to put the parentheses there. Mine comes up automatically on one side at least. And I get 0.778. That means 10 to the 0.778 is roughly 6. And the last one, log of 2,760. Log of 2,760 is equal to, I don't have to actually end the parenthesis on my calculator, you might have to on yours, is 3.44 roughly. So again, if I put that in, what that answer is telling me is 10 to the 3.44 power is equal to approximately 2,760. Okay, moving on here. The next part of this lesson is covering anti-logarithms. So a logarithm is going to help us find exponents. If we can remember that, that's going to be very helpful. So when we type in a logarithm, what we're finding is an exponent. So an anti-logarithm, a logarithm is equal to an exponent. So this is page 4, I believe, in your notes. If you have not printed those off from Blackboard, you should stop and do that right now. So, for example, let's say we have the log of some variable w is equal to 3.8774. So now I'm solving for w, the argument of the logarithm. Now, I want you to be thinking about what is the base. The base for this is 10 because there is no base written. So one way to do this is, well, this is how you want to do it. When you're solving for a logarithm, you're going to want to rewrite it in exponential form. So we have our base 10. And remember, a logarithm is equal to the exponent, so that's going to be the exponent to the 3.8774. That is what is equal to our w, our variable in there. So there is a button on your calculator. You can just type in 10 and raise it to the power of 3.8774. But if you have one of the calculator like my calculator, and actually probably most, look at this one right here, see if it has that button. Yes, it does. Most calculators are going to have a key that looks like this, 10 to the x. So if you're solving for a logarithm like this, if you rewrite it, it's going to look like this, and we're going to take 10 to the 3.8774. So if you want to do this quickly, what you can do is hit the 10 to the x key on your calculator and then just input this exponent. So it looks like this. So let me clear that. So the 10 to the x key is it's right above the log button, and so I need to hit the second because I need to get to that blue 10 to the x. So it'll bring up 10 to the power of, and then I need to type in my exponent, which is 3.8774. Hit enter, and I'm getting this answer 7,540.497, approximately 0.5. And so that's what w is equal to, and that means that 10 to that power is equal to, the log of 7,540.5 roughly is equal to 3.8774. Okay, so let's go on here. So w was approximately 7,540.5. All right, so it means 10 to this power, so log of 7,540 means 10 to this power is equal to 7,540. So a logarithm equals the exponent. All right, so here's a couple for you to try. You should try these example 2A and B on your own, and then come back and check your work. So for example A, I'm going to type in, I can just hit the second, 10 to the x, and then type in negative 2.101823, and I get 0.0079. So the log of 0.0079 is negative 2.101. And so my x value here is approximately 0.0079, and the meaning is 10 to this power is approximately equal to 0.0079. And if you think about what, okay, let's go through this. 10 to the 0, anything to the 0 is 1. 10 to the negative first power is 1 over 10 to the positive first power, which is 0.1. So, and 10 to the negative second power, let me move these up a little. 10 to the negative second power is 1 over 100, 1 over 10 squared, which is 1 over 100, which is 0.001. And 10 to the negative third power would be 1 over 10 cubed, which is 1 over 1,000. And that as a decimal is 0.0001. And you can see that this is in between these two values. So it makes sense. Hopefully it makes sense. And then for B, you should get x is approximately equal to 1,272.04. The meaning, again, I just want to go through this so this kind of gets drilled into your brain. 10 to this exponent is what we're finding here. 10 to the 3.045 is approximately 1,272.04. And if you think 10 cubed is 1,000, and 10 to the 3.1045 should be a little bit more than 1,000, makes sense. All right. So the next set of problems here is trying to solve this without a calculator. So using your logic here, all of these, there's no base written, so they're all base 10. So for C, it's 10. I'm finding this x, and if I rewrite it in exponential form, it's 10 to the negative first is equal to x. So, and 10 to the negative first is 1/10 or 0.1. So x, the log of 0.1 is equal to negative 1. So x is 0.1 there. Here for D, 10. My computer has trouble tracking with me here. 10, that's slow. So the base 10 to this exponent is equal to the argument of the logarithm, which is my x value. So 10 to the 5th, to write that out, basically you're just going to put a 1 and 5 zeros, whatever this exponent is. If it's 10 to an exponent, it's going to have that many zeros. 1, 2, 3, 4, 5, and that's 100,000. So you guys try E and F, come back and check. So pause the video and do those, and then see if you get the same thing that I get. This is 0.01. It means 10 to the negative second. When I'm finding this, 10 to the negative second is 1 over 10 squared, which is 1/100th, which is 0.01 as a decimal. You can write it as a fraction or decimal, doesn't matter. And then this last one we've been through, 10 to the first is what x is equal to, which is just 10. All right. Next one. You'll have problems like this in your homework. The log of x is equal to the log of base 5 of 25. So this base right here is a 10. And let's figure out what this is over here. What is that equal to? So we can use one of our identities. I can rewrite the log of base 5 of 25. 25 is the same thing as 5 squared. And I can use my power property and bring this 2 down in front. 2 times the log of base 5 of 5 is equal to 5 to what power equals 5 is what this is asking, and that is 1. So log of base 5 of 25 is equal to 2 times 1, or just 2. So I can rewrite this. This is the log of x on this side. equals 2. So then working from there, like we were just doing an example